In this video, I'm gonna get you started on the like dissolves like practice work. It's pretty simple. I'm gonna do 3 of the problems and then I'll give you a partial answer key so you can check your work. But let's get started. So the first thing you have to be able to do is you have to draw these compounds out. And you have to draw them out correctly. And then you have to apply your symmetry rules, which is SNAP, to this. So for H2O, it's clearly asymmetrical and polar. For CH4, it is, symmetrical and therefore nonpolar. Now, probably gonna make it worse there. Good enough. So now when you look at oil, oil is not a specific, it's just a generalized category. Oils are long chain carbon molecules, so think of them as lots of carbons in a row in a straight line. That's going to make them symmetrical, and oils are going to be nonpolar. So oils are nonpolar materials as well. So now let's do 3 of them down here. I'm going to do HF, H2, and CO2. HF, clearly asymmetrical, and therefore polar. H2, symmetrical and nonpolar, and CO2, also nonpolar. So now here's what you're going to do. It's real simple. If these are your solutes, these are your solvents. If they dissolve in each other, just give it a check. So, for example, HF will dissolve in water. The reason? Like dissolves like. They're both polar. It will not dissolve in oil because they're nonpolar, and it will not dissolve in CH4 because, again, polar likes to dissolve in polar, not nonpolar. So I'm just going to check off H2O. I skipped these 2 so you can do them, but these are the only. That's why I'm not leaving these blank because I didn't do them. I'm not leaving them blank because they don't dissolve. I'm leaving them blank because I'm leaving them up to you. For H2, well, it's nonpolar, so it's not going to dissolve in water, but it will dissolve in oil or CH4 because they are nonpolar. CO2, it won't dissolve in water, but it will dissolve in oil or CH4. Now, if you notice this, what's going on, it's actually going to be very easy. The polar solutes, I guess you could say it. So the polar solutes are here on the left side. Sorry, I had a little brain fart there. So the polar solutes on the left side are going to dissolve in all the same things. So what you're going to notice is that if it's polar here, it's going to have the same check pattern as all the other polar things on this page. And if it's nonpolar, like these 2, then they're going to dissolve in the exact same things like all the other nonpolar things on this page. So there's really only going to be 2 patterns of dissolving. The polar things are all going to dissolve and they're all going to be checked off together, or the nonpolar things are going to dissolve and they're all going to be checked off together, and there's going to be no mixing between the 2 in terms of which ones get checked off. Now there is a back. If you notice with the back page, just be careful because I threw in some carbon or CH4 variants. In other words, this is CH4. Here I lost 3 H's and gained 3 F's. Here I've got 2 and 2. Here I've got 3 and 1. Here I've got all 4 F's. So I think normally, I think there might be it's not a typo. You can handle this. But normally what I do is I take 1 H away, add an F. Take another H away, add an F. Take another H away, add an F. And then take the last H away, make it all F's. I kind of jumbled them up here, so just be aware that it's not the same pattern that I normally use in all my stuff. I just kind of mixed it up, but you should be able to handle that. We've got 2 variants over here, CH2, Br2. The thing to be careful here is this one is symmetrical in 3D, no matter how you draw it in 2 dimensions. So therefore, you're just going to have to make sure I would just draw this one symmetrically, whereas this one is going to be asymmetrical no matter what you do. And so that's going to change its polarity. So I want you to finish the whole back. Again, the check pattern on the back is going to be different from the front because the solvents are not in the same, they're not the same solvents, right? Water's still water, oil's still oil, but the remaining three are different. But within this page, the check patterns will be the same. The polar things will have the same stuff checked off, and the non-polar things will have all the same stuff checked off, and there will be no overlap between the two.